Good day, students. You are welcome to Nelstar tutorial. My name is Justin Water. This is my number on the board. Subscribe to my channel. I will be handling you on the following subjects or courses: general mathematics, physics, chemistry, basic programming, additional mathematics, computer science, statistics 1, calculus 1, mathematics A level, which I break under pure mathematics, statistics 2, mechanics, calculus 2, then calculus 3, differential equations with boundary value problems, advanced differential equations, and spectral functions. Subscribe to my channel for more updates on all these courses and subjects. Also, if you need thorough knowledge or extra assistance with respect to any subjects or any topic in any of the courses areas I mentioned, or maybe you are writing an exam and you need to be assisted or guided, send me a text through my number. Send me a text through my number. That topic, mention it. I will teach the topic and send a video of that topic to you. In addition, I will also give you assignments which you will do. Send the assignment to me. I will mark it and send you back. Thank you very much. For today, let's look at number 4. Subject there called basic programming. Basic means beginners all purpose symbolic instruction. Good. Now we have to explain. Computer science has its terminologies. And one of the commonest terminology we see in computer science is this word: hardware and software. Very, very important. All the hard aspect of that computer is made of. Is it the keyboard, the monitor, the CPU, all this inside, all these hard objects inside, they all belong to the word called what? Hardware. But what is software? Software is a set of instructions that guides the computer on what to do, what approach to follow. Do this, which the computer only understands. This software is not visible to the naked eye. You cannot see it. We write it with hand. After writing it with hand, then we now encode it into the computer for the computer to understand, to see, to follow the direction and give us what we want. Now, the best way now we can understand the hardware and software is this. We have the music system. DVD, this is a music system. DVD, or a music system, a playing system, like the DVD machine. Fine, DVD machine. The DVD machine itself, together with whatever thing is used to do it, is what? Hardware. But the type of music it plays, is it playing which music? Is it Bob Marley music? Bob Marley music. Is it Celine Dion? Is it Mariah Carey? Whichever music is playing, whatever music is playing can be viewed as what? Software. Remember that music is playing, even where that music is recorded, that CD, the DVD, that RAM DVD, where that music is recorded, it's still hardware. But that music inside it, you cannot see, is the software. So that's the approach, the way you have to understand it for now, the way I feel you can understand it for now. The DVD machine, all the components used to make it, whatever it is, because if you open inside the DVD, you see things like this, all this electronic items, all these electronic, they're all hardware. Then when the hardware, now you're not free to put any type of music you want. Is it Bob Marley music? Is it Celine Dion? Is it Mariah Carey? Is it Don Williams? Which musician do you want? Is it Jimmy Cliff? All those different type of music recorded on that CD, you cannot even see what is inside it. But when you put inside it, slot inside the DVD machine, you start playing. Those things are called software. The DVD, the circular disc itself, the plastic is even hardware. But that music we cannot see stored inside this around this thing is what? Software. That is very to understand it for now. Now, basic programming is concerned about software. It is a software. And we have different types of software which we can use to communicate with the computer. One of the commonest one is the one we call basic language or basic programming language. It is called beginners all-purpose symbolic expression code, which was developed in 1964. Now, this is a basic programming language. Since 1964 it came out, it has undergone some form of improvements. Because when they improve it, they call it another name. That's why now if you go to the market, we have different names for it. We have what we call GW Basic. We have Cassette Basic. We have MOF Basic. We have Basica. We have Quick Basic. These are different forms, various forms of basic. But before we talk more about this basic and all not, there's something we need to explain. We have different types of softwares, and these are languages you can use to communicate with the computer. There are many of them in the market. Different companies have their own different distance. We know the one we call COBOL. Using business is a programming language or common business oriented languages. We have the one we call Python. We have the one we call C++. We have the one we call Oracle. And then this one we are interested in now, basic. ETC, there are so many in the market. Use it the one you want, depending on what you want to achieve. And I don't think that it's impossible for any human being on earth to know all the programming languages, even if you're a professor of computer science. So the ones you know it very well, because on most occasions, what one A can do, the another programming language can also do the same thing. Fine. Now, these programming languages, which we normally use to teach students, is the one we call the basic language. Beginners all-purpose symbolic instruction code. Is more or less easier to understand. basic programming language has what we call keywords. What we call keywords. Keywords. And what makes it easier to understand that these keywords are words drawn from the English dictionary. That's why it says it's easier to understand. These keywords of basic programming language, they are what I have here. I say basic result words index. Look at them. They are what I have here. These are basic result words, programming language. All the words you see there are words of English that came out from the English dictionary. That was how all those words I picked. I see them. I see them. Any word you see here is from the English dictionary. And files, print, input, and whatnot. All these are English words from the dictionary. That's why we say that basic programming language is easier to, at least easy to understand compared with other programming languages. When they improve on a particular word, when they improve on a particular, when they add more keyword to a basic language, they can change the name. It can now become GW Basic. When they add more keywords to that GW Basic, they may change to Cassette Basic and whatnot. That's how all these names came to evolve. But the main thing that all of them are what? Basic programming language. And they more or less follow the same procedure. Now you can go to a local engineer in your area and tell him to install any of these versions of Basic into your laptop. Tell him to install GW Basic or Cassette Basic or Basica or Cook Basic into your system. Because all these programming languages, the essence is to enable us what? To compute, to communicate with the computer. These basic reserved words is gotten from the English dictionary. At times, keywords, at times we call them what? Commands. Once computer sees any of these keywords, if you see this, like in the computer, I do instruction, I see this word print, P-R-O-I-N-T. This is an English word. Once computer sees this thing print, the cost of the program is the software. Once he sees this word print, the computer knows what to do. Because those that wrote the software has written a program. The computer will go, open a file about this print, follow the instruction written in the machine language. The function will give instruction that what? You should what? Print something from the or maybe something on the screen. Print it on what? Paper. Now, these commands, keywords, we call it commands. Every programming language has its commands or keyword. One, every programming language has its rules and regulations. And when you're writing the program, you must follow the rules and regulations. If you don't follow the rule and regulation and they tell the computer to operate, to execute, the computer will tell you that he can't. Or you see an error message telling you that you don't follow the rule and regulation of that programming language. So now, every programming language is divided into every programming language every command, call it command. If computer, you have to copy a command or use the word statement. It's divided into the following. A, input command stroke statement. B, processing command stroke statement. C, decision command stroke statement. D, output, command statement. E, closing, command statement. Now look at the other one. I have E, A, B, C, D. E, increment. EF, output. And then closing statement, closing. Now this has to be explained properly for us to follow and for us to understand what's happening. Any set of instructions you give to a computer called a statement. That statement is made up of various different parts of this thing, or what I can call if-diok. This one is this one is I from here, P from here, D from here, I from here, O from here, C from here. What I call if, if, D, I, O, C, if-diok. Any programming statement which you give a computer to follow to execute a program, that statement is made up of different parts. It must have an input command or an input statement. It must have a processing statement. It must have a decision statement. It must have an increment statement. It must also have an output statement or a closing statement. Get me right. It doesn't mean that all these things must be there, but compulsorily, input must be there. Compulsorily, on most occasions, processing must be there. Compulsorily, output must be there. And compulsorily, closing must be there. These ones, decision and increment, they are optional. It depends on the type of program, whether it involves decision or whether it involves increment. It varies. But the input is always there. Yes, we told the computer must have an input. It has an input. And what I expected something that comes out and information that is comes from output. There must be a command that you tell the computer to stop. If you don't tell the computer to stop, the computer will be marolling for years, thousands of years until the battery runs down and it will not stop. But that once you see the instruction given to it at the end to close, end, terminate, depending on the version you are using. So different companies use different type of names to use. Some use close, some use end. Depends on the type of version you are using. Some even use stop. So these are different types of commands which you can use to end, terminate the end of the program. I think this is better understood when we write it. Let us write a simple program. For the simple program, we'll now explain other things. Cool. It's a very simple program. Now as I look at this program, I will explain other things. Let $20. Let's I told you that every computer, this is a simple computer program meant to solve a particular problem. What do you want to solve? The program to add two numbers. That's the instruction which you want to execute using the computer. Computer program to add computer program to add two numbers. The numbers are what? 30 and what? 50. I told you that a computer program is made up of how many parts? 1, 2, 3, 4, 5, 6. Input block. There must be input statement compulsory. There must be processing statement compulsory. Output must be there compulsory, and there must be closing statement compulsory. Decision and increment is optional, depending on what you want, the nature of the program. Some programs will need decision statements, so we need increment statements. We will come to that step by step. Now, these line numbers, computer will execute this program I've written here now, based on these line numbers. It will execute 10 first, before it comes to 20. After 20, now you get to the next one, 30. After 30, you get to the next one, 40. After 40, you get to the next one, 50. It will execute this program. I have decided to use 10. It's just for a matter of convenience. I think this one I wrote 20 here now. It may start changing to 11. This one may be 11, 12. That it just is so that it's just flexible. But don't say that the numbers must be in increments. For that, I will tell you more rules about it. It must not be fractions. Neither is it supposed to be decimals. It must be digits, integers. So 10, the first one here is 10. Once you execute what is 10, you say let L equal to 30. When the computer means this statement, it will go and draw a box like this. It will go to a box. Call it L and put 30 inside it. It has done that one. Now after 10, if you look for another number close to 10, if it's 11, you go to 11. If it's 12, you go to 12. If it's 13, after 10, the next number here is 20. Now if you go to 20, the next number after 10. On 20, it says let M equals this. You go to write M and put 50 inside it. This L, M, they are what you call location addresses. Location addresses. After executing number 20, you go to number 30. The next number after 20 is 30. If 21 is here, you go to 21. If 25, if 29. But if you can't see 20, after 20, the next number you see here is 30. You go to 30. Now you say, let P equals L and M. It will go, this is another location address. It will put P there. These are important statements. This is input statement. This is input statement, but this is processing statement. You can see the processor, the processing here. Plus, minus, divide, etc. They are all processing, command, or statement. They are all processing command. So this is the processing here. What the computer now do, when you process this thing, L and M, it will add 30 and what? 50. And place it inside the location address called P. When you add 30 and 50, when you put 80 here, just added it and put it in the location address called P. Now it goes to the next line. After 30, what the next one is 31 is not here, 32 is not here, 33 is not here, 38 is not here, 39 is not here. The next number closer to 30 is 40. it will now go to 40. And goes for that instruction. This is what you call the output command. Output O. There is no decision making here. There is no increment here. What the next one is output. You want to bring out what it has done. The instruction says you want print total P. Now, pay attention. When computer sees this quotation mark, quotation mark means copy and paste. What it means is that whatever thing that is inside this quotation mark is not going to touch it. It will just carry it as it is and write it for you. Computer will write total TAL. And now print P. What is location address P? What is inside the location address P? 80. Total 80. You go to the next line. What does he want you to do? You tell it to stop, end. Some version of BASIC, they use end. Some other version of BASIC, they use what? Stop. Is it still the same BASIC? And I told you the different versions of BASIC. Is it BASICA? Is it GW BASIC? Is it Cool BASIC? They are all talking about the same BASIC. So this is a very, very simple programming statement. Now, one thing about this thing is this. At the end, when you have finished that, this is after writing this thing with Biro on the paper like this. This thing now, you have to use your typewriter. Sorry, not the typewriter, the keyboard. Either the one here or the one in your laptop. And type all these statements. Type them, one after the other. 10, just type after typing all of them. At the end, after typing, now the computer, if you don't know the version, it will give you order to run the program. At times you see run. You see the keyboard, hey, to tell you to run. Or to execute, run, execute. Immediately you take run, in less than a second, this thing will appear, total 80. If you have typed this thing correctly, and if you have followed the rules and regulations for typing this thing, if you type it wrongly or along the line you made a mistake, as I told you, every programming language has its own rules and regulations. If you do not follow the rules and regulations in typing it, you may do line 10 correctly. Even when it comes to line 20, it will say that you have seen the program. But assuming that when you are typing this thing now, here, you are typing this thing now, you put full stop here, type M equal to 50. Once you get to this point, it will complain that this full stop here, it doesn't know what it is. Why it doesn't know what it is? Because those that wrote that programming language, that basic programming language, did not tell the system that something should be here, full stop. It doesn't know what it is. At this point, it will stop. Give you that there's an error, I should correct this thing, correct it. So if you are smart enough to see that, notice that this thing is wrong, that there's nothing wrong here, then assuming you clean this, you clean it. And give instruction now, run. It will run this one correct, run this one correct again, run this one correct. Run this one. Now, assuming you get to this point, you do something like this. The computer, those that control it may not understand, the system may not understand what system means. It's only programmed to understand when it's only one. Plus. It will add what is in location address M, and what is location address N, and location address M. Carry it and put another location address called what? P. Now, what if instruction for you to act? You write, now you give instruction, output, this is the output. This three is what? Input command, input. Input. This one is what? Processing. Processing command or processing statement. This one is output statement. Output statement. This one is what? Closing statement. If you keep this L and M and put the location address P, then the next instruction is now waiting for you is what? Print total P. Because this total, you put it in quotation mark. It's not going to touch anything here. What is going to computer is going to do is do what you call copy and paste. You carry this inside here now, total, and drop it for you now. They go to location address P and look for what is where location address P, which is 80. Now print 80 for you. That's the end of the program. Assuming in that location address, when it's trying to give instruction, this output command, this total, this is not like this. Print total P. Now the computer will be in confusion. It will tell you that it doesn't understand what this thing means. Those that programmed it did not tell him what this thing means, because this total is not a keyword. By keyword, well, as I explained to you, when you look at these words, the words here, you see, total is not here. So you do not understand what it means. The only way that total can make meaning to it is what? Or let's give it that total. I should handle it as what? Copy and paste. In quotation mark. You do not carry the total, drop it for you. They drop what is inside P. And that's the end of the program. Listen. Computer operates at the speed of light. The speed of light is 300 million meters per second. Simply written like this. So it operates at the speed of light. That's why you can stay here and give instruction to a laptop in your room here. It will go to the internet, it will go to the net in space, hacking in space. Thousands of miles from here in space. Go and get information from you from there. Come back to your laptop and drop it for you. Because it operates at the speed of light. That's what makes computer very, very fascinating. And these are the things we study under computer science. That is number 6, which I just taught you. Then we are now on number 4. Number 4 is just the programming language. The language that is used to communicate with the computer. Once more, there are various languages you can use to communicate with computers. I told you there are many of them. Even if you are a professor of computer science, I don't think I know all the computer languages in the world. We have COBOL, Common Business-Oriented Languages. We have Python. We have C++. We have Oracle. We have Basic, and so many others. So the one you want to know is the one you want to know. You know it very well. So what I'm using now to teach students is the one we call Basic. Simpler to understand because all the keywords are gotten from the English dictionary. Look at the keywords. Every word you see here, you look at it in the dictionary, normally, automatically you see it. Print, for instance, these are keywords. This is let, came from the dictionary, let in the dictionary. Print, dictionary word. End, dictionary word. And other keywords here. As we move along, we'll be coming to across all these keywords, one after the other. And we'll also be coming across all the other rules and regulations guiding the operation of writing of the basic language. So this is a very simple programming language which I have written. So by next time, we move to the next step. Thank you very much.